Hi, I'm Randall Heyman, a mathematics academic. You're on one of my Corona Help playlists where I make quick turnaround videos for students and educators to help them during the coronavirus. So if you'd like me to make a video for you, then send me an email or comment below any of my videos. So I have had someone who's taken that advice, Joe, who's sent me an email, actually to this address here, with a couple of problems. This is the first problem. Now, I think I may have mentioned in this one of my 150 or 200 videos, I'm not really that comfortable just going through a full solution to a particular problem that someone may have got at university. I remember when I was doing first year, my calculus lecturer saying very disparaging things about mathematicians who just put full-blown answers up on the internet to help people with their assignment, well, to actually do their assignments. So what I want to do here is, I don't want to be one of those disparaging mathematicians, or disparaged mathematicians, I suppose. So what I want to do is, Joe, is I'm going to give you some ideas, some hints, some ways of thinking about this problem and the other problem you sent me. And if you've got more problems, you can come back to me and we'll go from there. Okay, so this is the first one, the last 4 digits of 11 to the power of 8,012. Now, the first thing is you can't do this with a calculator, okay? The examiner has actually specifically set this to be way beyond what a calculator can do. Okay, so my guess is that you've been studying some sort of unit class modular arithmetic. This is normally where this comes up, this sort of question. Okay, so let's move this up and let's sort of create a table here. So what this suggests to me is that we should try and get it in some sort of expression or term or equation that involves modular arithmetic, because then some of the techniques that you've learned about for modular arithmetic are probably going to help you. So over here we've got the problem these sort of problems, and over here we'll put the modular arithmetic way of looking at it. So for example, if I said what is 3 to the power 5? If I said what is the remainder if I divide 3 to the 5 by 17, well, I would just say, let's just write that as 3 to the 5 mod 17. Okay, so now let's go and look at the problem back up here. I'll just direct your eyes back here. This is actually the problem we're trying to solve, the last 4 digits. So you might want to just pause and think about that for a sec. Is there some way that we can express the last 4 digits of 11 to the power of 8,012 in modular arithmetic form? If you can do that, well, then we can move on to the second part, which is just how do we go about solving the modular arithmetic expression. Okay, so if you've stopped the video and had a good think about that, and you can't progress, well then one of the things I said in a previous video is you just want to keep moving to try and solve these sort of problems. Don't get discouraged and give up, but just keep moving. Do something, do anything. Now, and one of the things you can do is simplify. So let's just say I said, what is the last, not the last 4 digits, but just the last digit of 11 to the 8012. So can you think of a way to express that? You might want to do an easy one. What's the last digit of, I don't know, let's just take a number, 78654. What's the last digit of that? How would we express that in modular arithmetic? And the way we would do that is 78654 mod 10. After all, if we divide this number here by 10, then the remainder is going to be the last digit. So what I'm saying is back up here, we could just write that, instead of writing the problem for the last digit, we could just go mod 10. Okay. Now, okay, so once we got comfortable with that, you might then want to look at, well, what's the last two digits of 78654? That's the 54. Well, here my thinking is 78654 divided by, this time 100. I'll get a remainder of 54. So let's make this 78654 mod 100. So when you get comfortable with that, we can go to what the problem was. What's the last four digits of 118012? I'm not going to answer that. I'm going to leave that for you to do. But if you have problems, you're going to come back to me, Joe, or anyone else who's watching this. Okay. So if we now look back, these are the sort of expressions that we're going to be asked to simplify. Yeah. I mean, the answer down here, that's what we've got to work on, but it's going to be similar to these. So it's going to be something like, so I suppose this is step 2, if you like. That was step 1. So what's step 2? Well, we're going to have something like this. We're going to have a to the power of b modulo c. Example 3 to the, what did I have before? 3 to the, I had 7864, but I could have 3 8 mod 17, for example. Let me just rub out those brackets. They're not supposed to be there. Oh, what happened then? Okay. In this situation, you're not really supposed to have the brackets, so I'll do the right thing. Okay. Okay, so how are you, so what we've said is you'll get to something here that is in this form. And what are you going to do with that? Well, what you're going to do is have a look at my video, modular exponentiation, made easy. And that should help you. There's a number of methods of ways of doing it. You can pick whichever method suits you best. If that doesn't work for you, then you could have a look at my, I've got a, this video itself will be in this. I've got a Corona Help discrete mathematics playlist full of videos. So you could have a quick flick through that as well, see if you can find anything to do with, you know, modular powers, modular exponentiation, something that might shed some more light on this. I may actually decide at some point to set up a new playlist just for modular arithmetic because I've had quite a few questions on it. So it'll either be discrete maths or modular arithmetic. Okay, so that's that one. Now let's go on to the next question, which I've got on my phone here. Solve 2x. I think this is what you mean, rather than x squared. I think you mean 2. Is that mod 23 by 43? Okay. So, word of warning in modular arithmetic, until you become very skilled and know what you're doing properly, don't divide. Don't divide in modular arithmetic. You can really come to grief. So, like normally, I would like to divide by 2. I would like to divide both sides by 2. That's what you would do if you're in high school. Forgetting the mod, if you just had 2x equals 35, divide both sides by 2. But we're saying don't divide. So how can you get the same effect? By multiplying. So what I would suggest is that you start to think this way. Multiply by the inverse of 2, i.e. 2 to the negative 1, or you could even think of it as a half, modulo in this modulo world we're working in, which is modulo whatever this is, 23 times 43. So how are you going to work out the inverse of 2? In other words, what number? So what I'm saying is solve 2x equals 1 modulo 23 by 43. Okay, so the way that you're going to do that is you're going to have a look at my video modular inverse made easy, and it will tell you how to do that. So once you've got that inverse, say the inverse, remember we're in this world, so a number, the answer can be anything between 1 and 23 times 43 minus 1. So the answer to this might be 122. Yeah, it could be 122. I don't know, something like that. So once you've got the inverse, you would then just go back up to here and multiply by that 122. And you know that 122 by this 2 here is going to give you 1. So all you've got left on the left-hand side is x. So all we're saying is basically, rather than like in high school or primary school where you would divide both sides by 2, you're just going to multiply by the inverse of 2. But there's a bit of a process to work out the inverse of 2. You don't want to be checking all the numbers up to 23 times 43. And you can do it. So have a look at my video, Modular Inverse Made Easy. But what it involves is basically the Euclid's algorithm, and then the extended Euclid's algorithm. And once you've got that, then you would take the modulus of both sides, and out spits the inverse of 2. So I'll leave you to have a look through that. Once again, Joe or anyone else, if you've got problems with it, come back to me. That's all I wanted to say on this. If you've got any questions on mathematics at all, then comment me or email me, and if I think I can help you, I will do so.